Look at these waves. They're perfect for surfing. Hey Sarah, come see.
Oh my gosh, they are.
Do you want to go ride these waves?
I'm sorry, we have to talk about scientific waves.
Hi, I'm Professor Stewart, and today we'll be talking about destructive waves. First, destructive waves. There are two types of destructive waves, and the first we'll talk about is the destructive waves that cancel each other out. This is when two equal waves combine to create a 180 out of phase line, which looks like this. Next is when different waves come together, which look like this, or this, to create a completely different wave that could look like this, or anything different from the previous waves. And that's what destructive waves are. Now, for constructive waves, this is when the same waves add together to create a higher amplitude than the original waves. An example of this could be one wave and an equal wave, making a completely different wave with higher amplitude. As you can see, this wave has a higher amplitude. Hi, welcome back to Professor Amy's next class. Today we'll be talking about thermal equilibrium. This is when two objects, which can be any two objects, and one has a higher temperature than the other. Here, for example, one box is 76 degrees, whereas the other one is 30 degrees. This means that the thermal energy is being transferred from the object with the higher temperature to the lower temperature. In this case, it is the 76 degree box to the 30 degree box. Even when this box reaches 76 degrees, which means that both boxes will have the same temperature, the thermal energy continues to be passed between these objects, yet in this case it is being passed back and forth so that each object maintains the same amount of thermal energy. Welcome back to Professor Amy's next class. Today we'll be talking about solid, liquids, and gases and the differences between them. First, let's start with solids. Solids are substances in which particles vibrate in a fixed position with fixed shape and volume. This is key to being a solid. This means that if a water is more dense, particles in a solid will have less kinetic energy than those in liquid or gas. Now for liquid. Liquid is the state in which particles in a substance vibrate so that the substance is fixed or constant volume but a flexible shape. Lastly, gas is a phase of matter in which particles of a substance vibrate in a random pattern. Along with gas, plasma is a phase of matter in which the atoms in the gas have been ionized. First, conduction is the transfer of thermal energy from one substance to another through direct contact. For example, this could be when you're boiling a water. The water is in direct contact with the heat. Next, convection is a transfer of thermal energy through the movement of a liquid or gas. This means that convection needs a medium to transfer the liquid or gas. An example of this is when you boil a pot of water, the water moves through circular patterns because of this convection. Finally, radiation is the transfer of energy through matter or space in the form of electromagnetic waves such as visible light and microwaves.
Now we're going to take a look at parts of a wave. To start with, the crest is the top of a wave, as you can see here. The trough is the bottom of a wave, right here. The amplitude is the distance from the node, which is this orange line, and so it's the distance from the node to the trough, or the distance from the node to the crest. To find the wavelength, you first start at the first node here, and you go to the next identical node on the wave. So if we start here, that is one complete wave. And then to the next identical point is right here. That is two complete waves. This wave only has a total number of 2 waves. Even though there are 1, 2, 3, 4, 5, 6 nodes, there are only 2 complete waves. Have you ever wondered what frequency and period are?
Oh yeah!
Well, I'm here to tell you. Frequency is the number of complete waves that pass a given point in a certain period of time. Here is an example. First, you must know that frequency equals 1 divided by t. T is short for period, and F equals frequency. If you have a period of 5, you do F equals 1 divided by 5. F equals 20 hertz. The unit for frequency is hertz. Period is the length of time for one oscillation. The equation is T equals 1 divided by F. T stands for period and F stands for frequency. In an example, if you have a frequency of 4, you do 1 divided by 4, which equals 0.25 seconds. The unit for period is seconds.
Hi, and welcome to Wave Schools. We're going to talk about the basics of waves. And here are the basic vocabulary that you need to know. Pretty much, what is a wave? A wave is a disturbance that transfers energy from one place to another. A medium is a substance that doesn't move within the wave. The next vocabulary word that you need to know is a mechanical wave. A mechanical wave is a wave that requires a medium to travel through. Welcome back. Now we're going to talk about 2 types of waves. There's a transverse wave and a longitudinal wave. The definition of a transverse wave is a wave that moves the medium perpendicular to the direction in which the waves are traveling. And a longitudinal wave are waves that move the medium parallel to the direction the wave is moving, like a push and a pull. Now we're going to show you a video on longitudinal and transverse wave.
Yeah. Miami. South Beach, bringing the heat. Can y'all feel that? Can y'all feel that?
Welcome back. We're going to talk about temperature. The definition of temperature is a measure of the average kinetic energy of all particles in a substance. Help me, doctor.
Oh goodness, let me take your temperature. 40.55 degrees Celsius? Let me go to my lab. Welcome to my lab. We're going to find out Sarah's degree temperature in degrees Fahrenheit. Let's take a look. Her starting temperature in degrees Celsius is 40.55 degrees Celsius. Let's plug that into our equation. Fahrenheit equals 1.8 times degrees Celsius plus 32. Okay, so we have 1.8 times 40.55 plus 32. Her total degree temperature Fahrenheit is 105 degrees. She has a fever. Let's take a look at Sarah's temperature in degrees Kelvin. The formula for Kelvin is degrees Celsius plus 273. If Sarah's degrees Celsius is 40.55, then we add that to 273. We get 313.55. Hi, we're going to explain the phase diagram. So you start off by sublimation / deposition on this line right here. Sublimation is when a solid turns into a gas, like dry ice. Deposition is a gas to a solid. And then from this point right here is called the triple point, where all three phases can take place. If you go up left, you will reach melting/freezing. Melting is when a solid turns into a liquid, and freezing is when a liquid turns into a solid. If you go from the triple point to the upright, then you will reach boiling and condensation. Boiling is when a liquid turns into a gas, and condensation is when a gas turns into a liquid. The three phases take place in this diagram: solid, here, liquid, and gas.
This is an example of a heating curve. Okay, we start right here, and this is where solids happen. Melting is going up while freezing is going down. Then we have the liquids. Well, we have evaporation is going up and condensation going down. And then we have liquid and gases and gas. And we have exothermic going down that way and endothermic going down that way. Okay, now we're going to talk about conductors and insulators. A conductor is materials that lets heat and electricity transfer through the object. Good examples of conductors are aluminum, silicone, steel, iron, and copper. Next, insulators. Insulators does not allow the transfer of heat or energy through its materials. Examples of insulators, of good insulators, are plastic, wood, wool, glass, cloth, sand, and paper. Hi, welcome back. Now we're going to talk about wave speed calculations. So, the formula for wave speed is wave speed equals wavelength times frequency. This backwards y thing is the sign for wavelength. So here's an example. So if the wavelength is 5 meters and frequency is 6 hertz, and then so then we would say wavelength equals 5 times 6, so which is the wavelength is 30 meters per second.
We learned about scientific waves.
I know, aren't they fun?
Yeah, they're almost as fun as riding the real waves. Let's go.
Okay. Yeah.